Hello children, welcome to the third chapter of physics, that is machines. So let us see, here you can see in the screen itself there are different simple machines which I have shown. So we are going to understand different concepts and in detail about these machines. So now here you can see that I have shown a screw, and here I have given two planks, and this is how I want to fix this particular screw into this plank. Now think over it, children. Can you do it? Do this particular exercise of fixing this particular screw into the plank without help of any simple machine? Think over it. So your answer will be no. So now, if I provide you with this tool, is it going to make your work easier? Definitely is. So what the screwdriver will do is it will help you to fix itself in this groove. You can see over here there is a groove. So you can fix this screwdriver into this groove, and with the help of this screwdriver, this particular screw can be easily fit into this plank. So what is this screwdriver helping you to do? So it's helping you to change the point of application of the effort in a convenient point. So because of this particular screwdriver, it can fit into this groove, and because of that, when you fix this particular screw into this plank, and on its head, on the groove on its head, if you fix the screwdriver, and then it will help you to change the point of application at a convenient point, so it will go in easily. So this is one of the use of the simple machine, that is changing the point of application to a convenient point, okay, of the effort. Second, you can see over here there is a well, and this is a very deep well. From here you need to remove, or you need to lift water from this deep well. Now children, what you will be doing is, with the help of this rope, when you have to lift the water, you will be applying the force in upward direction. So now think over it, how this particular machine which I'm going to give you now is going to help you to draw this water out of the well easily. Isn't it going to make your work easier? So yes, this particular simple machine, which is known as pulley, will help you to pull the rope in downward direction, because if without pulley, if you're lifting it, you're going to pull it in upward direction. But because of this pulley, as this particular rope is, you can see it that it is turning around it, and because of that your body weight is going to help to pull this rope very easily. So what is this pulley helping you to do? So it's helping in lifting the heavy load with less effort. So this particular heavy load which you had to lift, you can, with the help of this pulley, the effort which was required to pull or to lift this water or this heavy load is now decreased. So your effort is reduced. So this is one of the function of a simple machine. Second, it also helps in changing the direction of the effort to a convenient direction. So it is changing the direction, and because of this change in the direction of the effort, it has become convenient for you. So changing the direction of effort to a convenient direction. So this is how the simple machines help you to make your work easier. One is decrease the effort. Second is changing the direction of the effort. Now in the third picture, you can see that this is one more simple machine, scissor. Now this is the cloth which you have to cut. Okay, so now you cannot cut it the way you want if this scissor is not there. So this scissor is going to help you to cut this particular cloth in a particular shape. And what is it going to do? It's going to definitely save your time. So it helps to obtain gain in speed. Whatever work, if without this scissor you have to cut this cloth, think how difficult it would be. So it's going to definitely slow down your work. So with the help of this scissor, your speed of doing this particular work, cutting this cloth, is going to increase. So this is how it will help to obtain gaining speed. So these are the four uses of the simple machines which we have seen right now, to change the direction of the effort to a convenient direction, to change, to apply the effort at a convenient point, to decrease the effort, and to gain the speed. So it acts as a force multiplier, because if it is decreasing your effort, it acts as a force multiplier. And if the simple machine is helping you to do that particular work in less time, then it is gain in speed. So these are the four uses of simple machine which you have to learn. It's very important from scope point of view also. Okay, so make a note of it in your textbook. After that, we go to the next point. The term which is very important, the definition which you have to learn in this chapter. What is load? Okay, so now you might be thinking, what is the meaning of load? So here you can see this particular work, because you have to load this object into the truck. So when you have to load this, you have to put these boxes inside it. The work which you are planning to do with the help of machine, that particular force which you have to lift, in the case of well also you have seen here, you have to lift water. So the force which you have to overcome with the help of machine, that work or that force is known as load. So here also you can see, in this case, the machine is used to uplift this load. So the load or the weight which has to overcome with the help of machine, that is known as load. So here you can see the definition of load is the resistive or opposing force to overcome by a machine. Means the work or the force which has to be done. You cannot use the word work, you have to use the word force. The reason is it has got certain weight, and when you want to lift anything or you want to drive anything into a particular point, you want to cut, so you are trying to overcome the force, the resistive force, with the help of that machine. So to overcome, or the resistive or the opposing force to be overcome by a machine, that is known as load. So as it is a force, what do you think the unit, SI unit of the load will be, as the word force is used? So let us see. The SI unit of the load is Newton, which when you're writing complete name, N should be small. And when you're writing only the abbreviation, N should be capital. And what is the CGS unit? Dyne. So I hope till here, children, everything is clear. Now we go to the next slide. The next slide is, you can see over here. Now this particular lady is trying to push this load. So suppose if you assume that this is a resistive force which the machine has to overcome. Now this lady is pushing it. Now think that this is a robo and the robo has to overcome this resistive load. Then the force which is applied by this robo is known as effort. Okay, so what is effort? The force applied on the machine to overcome the load is called effort. So it is applied or on the machine to overcome the load, that is called effort. Okay, so that is the effort, meaning of effort. You have to learn all these definitions. Now what do you think will be the SI unit? As it is the force, it is Newton, and CGS unit is dyne. Now the next term which is very important, you can see machine versus man. Nowadays our life is impossible without machine. For simple things we require machine. Okay, scissors. Now these are all machines, pluckers. These are used by us every day, and we cannot think our life without that. So why, we use these machines? Now you might be thinking that so many machines we use: stapler, tongs. When we get up in the morning, we are going to use tongue cleaner to clean our tongue, if even that's a simple tool or a machine. After that, if you have started making your tea, You are going to lift the vessel with the help of these tongs. So even that is a simple machine. So why these simple machines are used by us? Because what it does is it is making our work easier. So when we say making our work easier, the term which comes to my mind is mechanical advantage. Because it is making our work easier, it is helping us to overcome the load. So it is known as mechanical advantage. Mechanical advantage means it sometimes decreases the effort. So it helps to multiply the force which we are applying. So that's why our effort decreases. Second thing is it helps us to save our time. So it is gain in speed. That's why it is known as mechanical advantage. Mechanical means whatever work we are doing, it is helping us to make the effort from our side easier and also to save the time. So now let us see what is this mechanical advantage. When we are talking in terms of physics, we always denote any term with the help or using the formula or developing a relation. So when you're talking about load and effort, so the ratio of load to the effort is known as the mechanical advantage of a machine. So whether it's going to help you to decrease the effort, that means force multiplier, or it's going to save your time, that is gain in speed, or it is helping you to change the direction of the effort applied. So all this, if it is doing, that is known as mechanical advantage. So the value for mechanical advantage, what we have found is by taking the ratio of load to the effort. Okay, so here you can see as it is a ratio of load to the effort, it has no unit, because you can see load, we have seen that in the last slide it is denoted with the SI unit Newton, and effort is also denoted with the SI unit Newton. As Newton gets cancelled, it has no unit. Now you can see it changes due to friction. So it changes due to friction and weight of the moving parts. So if there is friction between the moving parts, and when you are talking about a simple machine, there are different parts and it has got weight. So because of that weight, the mechanical advantage is always going to differ due to the friction and due to the weight. It's going to decrease or increase accordingly whenever machine is in use. So it changes due to that. It's going to be affected. Now the next topic what we are going to understand is there are difference in mechanical advantage. So when mechanical advantage is greater than 1, as I have told you, mechanical advantage is load upon effort. Now when is it going to be greater than 1? Think over it. When the numerator is going to be greater than the denominator. That means here we can see that load is greater than effort, as load is in the numerator and effort is in the denominator. If load is greater than effort, then only mechanical advantage is going to be greater than 1. So if it is greater than 1, the machine acts as a force multiplier, because now as the load is greater and the effort which you are applying is very less because of the machine, so that particular machine is acting like a force multiplier. Okay, it is helping to decrease your effort. So in case of we will be seeing with the help of levers, we are going to understand this particular thing, mechanical advantage. That time you will understand it in a better way. Then next is, suppose if the machine is used to change the direction of effort, so what is it going to do? As you have seen in case of a pulley, which we have seen, it is fixed on the well. There it is changing the direction of the effort. First, the effort was in the upward direction, but because of the pulley, the direction of the effort changed. So now in that case, load and effort are equal. And when load is equal to the effort, MA is equal to 1. So when MA is equal to 1, load is equal to effort, means numerator and denominator are equal. And that's why this particular machine is only helping to change the direction of the effort. It is not force multiplier, it is not gain in speed, which we are going to see next. It is only helping us to change the direction of the effort. Okay, children, is it clear? Now we go to the next. If effort is greater than load, denominator is greater than load. In that case, children, what is going to happen? If denominator is greater than load, then MA is definitely going to be less than 1. And then in that case, it is gaining speed. As in case of scissors, you have seen that it is going to help you to gain the speed. So, uh, you can say that the MA of the scissor is less than 1. So I hope till here it's clear. MA greater than 1, equal to 1 and less than 1. Okay. Now the next thing or the next term, which is again very important, we have to understand. Before going to the next term, I want to ask you a question. So the question is written on this slide. So can the machine, here it has to be H, children. So please make a note of it. The H is missing over here. It is machine. Okay, just a minute. So just make a note of it. It is machine over here. H has to be there. So can the machine act as a force multiplier or gain in speed simultaneously, children? What do you think? Think over it for a little while and try to answer this particular thing. So let us see the answer. Whatever you thought, keep it in your mind and let us see what the answer comes. So it is no. So why do you think that a machine cannot act as a force multiplier and gain in speed? Those who have thought that no, it cannot, all are right. So you all have got the answer correct. So here is the reason, as the MA of a machine, that is mechanical advantage of a machine, cannot be greater than 1 and less than 1 simultaneously, because we have seen that if MA is greater than 1, the machine acts as a force multiplier. If MA is less than 1, it acts as gain in speed. As MA cannot be greater than 1 and less than 1 simultaneously, means at the same time, that's why machine cannot act as a force multiplier and gain in speed at the same time. So I hope children till here about mechanical advantage is clear. Now we go to the next slide. Now in the next slide you will see velocity ratio. What do you think might be velocity ratio? Now when we are talking with respect to the load and the effort, you must be saying that in case of when we are pulling the load, okay, with the help of simple pulley, that is pulley which is a fixed pulley on the well. So you are going to lift the water. So water is a load and the force what you are applying to lift that water is the effort. Okay, so your force is the effort and the weight of the water is the load. So don't you think that whenever you are lifting the water in the upward direction, that is you are lifting it from the well, so it's moving, it is getting displaced. So when it is getting displaced, the force what you are applying on the rope, even that is undergoing displacement. So both are getting displaced. So that particular displacement, what is undergone by both the forces, load and the effort, that is known as velocity ratio. So let's see the definition. The ratio of the velocity of effort to the velocity of load, means with what speed the load and the effort both are moving, that ratio of both velocity of effort and velocity of load is known as the velocity ratio. Now children, when you are writing velocity ratio, please make a note of it that velocity of effort is up in the numerator, because when you are writing mechanical advantage, load is in the numerator and effort is in the denominator. So MA is L upon E, load upon effort. Okay, but when you are writing velocity ratio of a machine, Velocity of effort is in the numerator and velocity of load is in the denominator. So VE upon VL. This should be your definition also and formula also. So this is the relationship. If the relationship is asked, you have to write it in this format. Now next, is there any unit for velocity ratio? So no, it has no unit. As you can see, it is a ratio, it has no unit. Velocity ratio is also written as displacement of effort upon displacement of load. As I told you that both are getting displaced. So as you can see, the time, we are going to keep it constant. And when we are writing velocity, velocity is displacement upon time. So time, because both are same, it gets cancelled and we can write it as displacement of effort upon displacement of load also. Okay, children, so these are the two formula which you have to remember with respect to velocity ratio. Now I want to ask you one thing. Will velocity ratio, because you have seen that mechanical advantage of a machine will be affected by friction and can be affected by the weight of the moving parts. But can velocity ratio be affected by the friction and by the moving parts? What do you think, children? Yeah, guess. So guess it, and then I'm going to answer you. So keep it in your mind and just check whether your answer is right or wrong. So velocity ratio is not going to be affected by the friction and by the weight of the moving parts, as you have seen in case of mechanical advantage. So velocity ratio will only change if you're changing the design of the machine. Okay, so if you're changing the design of the machine, then only the velocity ratio will change. Otherwise, it is not affected. Okay, children. So I hope till here it's clear. Now we go to the next term, which is again very important, as I told you. Work input. What is the meaning of work input? Now, when you are talking about input and output, I want you to remember with the help of this term, which I'm going to give you in the next slide. So first you understand that work input is the work done on the machine by the effort. Okay, as you can see that when I had shown you that what is the meaning of effort, that is, I showed you that the robo is going to help to push the load. So that means when you are pushing the load, you are applying effort. So the force on the machine to push the resistive force is known as the effort. So when you're talking about work done on the machine by the effort, okay, so as it is by the effort, it's known as work input. Okay, so please understand this term, it's very important. So when you're writing work input, as it is with respect to the effort, what will be the formula? Displace, as you know, work is nothing but displacement into force. You have learned this in last chapter. So displacement of effort into effort, as you know, effort is nothing but force. So DE into effort is going to be work input, is going to be work input. Now, you don't have to know the unit. It's going to be work, so joule, but it's not necessary for you to write according to the scope, but as it is work, it's going to be joule. Now, what is work output? Now, as you know that work input is related to effort, work output will be related to load. Okay, so the work done by the machine on load, that is called work output. So you have to remember output is related to load and input is related to effort. Now, when you're writing work input, you write DE into effort. When you're writing work output, you will be writing DL into load. Okay, I hope children till here it's clear. Now, efficiency. This is a next term which is very important with respect to machines. The thing is, whenever you are using the machine, you're going to select that particular machine so that it will decrease your effort and also it will save your time. So that is known as the efficiency of the machine. How like efficiently it will be helping you to do that work. So whenever you are talking about efficiency of a machine, it is taken as the ratio, because efficiency is in percentage, you are multiplying it with 100. So efficiency is equal to work output. Remember that output is going to be in the numerator and input is going to be in the denominator. So how are you going to remember this? That output is going to be up and input is going to be uh, in the denominator. So when you are arranging it alphabetically, so I comes first, but here you are going to write O up. So work output upon work input. So though I comes first, it will be in the denominator and output will be in the numerator. So when you're writing, when you're remembering, how to remember that output is related to load and input is related to effort, I've written this term over here, lout in. Lout in means you will remember lout output with load, in effort with input, lout in. So you can remember this particular abbreviation, so that you will remember that work output is related to the load and work input is related to effort. Now, lout in is going to help you to remember that. Okay, children. Now, as it is expressed in percentage, because you're multiplying by 100, it has no unit. It will be written as 80%, 90%, and no machine can be 100% efficient. The reason is it is only ideal machine, because in every kind of machine which is in use, there will be some kind of friction, there will be some amount of loss of energy in form of heat, and that's the reason efficiency can never be 100%. So you have to mention over here, I want to ask you a question here. Suppose if I ask you a question that can, I'm writing it over here, which you have to write in your textbook also, where efficiency is mentioned. Can efficiency of machine be 100%? Okay. So then what will be your answer? Can efficiency of machine, wait, I'll just erase this and I'll write it with the help of text box. So can efficiency of machine be 100%? Yes, children, can it be 100%? So what will be your answer? So in this case, please remember that your answer will be no. So please write it down. What will be the reason why it is no? Reason is there is friction between moving parts of the machine. And loss of energy in form of heat. And that's the reason any machine which is in use cannot have 100% efficiency. Only ideal machine is going to be 100% efficient, but that particular machine does not exist. The reason is there is going to be friction between the moving parts of the machine and loss of energy in form of heat. So please understand this and write this down. These are the important questions. So just remember louting, output, load, input, effort. Work input related to effort, work output related to load. And when you're writing the ratio, output in the numerator, input, work input in the denominator. arrange it in the form of A, B, C, D, E, F, G, H, I. So you will see I comes first, O comes afterwards in the alphabet. But though it comes afterwards, it is in the numerator and input is in the denominator. So it will help you for the derivation which we are going to do next. Now I'll clear this, but you please write it down. Now after this we go to the next slide. So in the next slide, you have to derive efficiency is equal to MA upon VR. So you have to derive this. Now how will you derive this? There are certain steps. Now as you have seen, formula for efficiency is work output upon work input into 100. Yes, children. Now you know that work output, how can you write work output? You can write it as load into, because output, as I told you, aim. Load is related to output. So output is L into DL. Aim means effort is related to input. So DE into E into DE, and into 100 will be written over here. Now because we are not, we are not writing it in percentage form, it is only efficiency. So we ignore this 100. Now as you know, MA is load upon effort and VR is D upon DL. We have seen that. So as it is D upon DL, 1 upon VR, if we are taking the reciprocal, it will be DL upon D, because here it is DL upon D. So it will be 1 upon VR. So when we substitute L upon E as MA and DL upon D as 1 upon VR, we get efficiency as MA upon VR. This particular derivation is very important from the scope point of view. Please write it down in your notebook. So now I hope till here it's clear, children. Now we go to the next slide. We are going to understand now about liver. Very important topic. Now what is liver? So in physics, if you see this rigid rod, which can be turned and is fixed at one point. And due to this turning effect, it can decrease the effort or increase the speed of the work done, or sometimes help in changing the point of effort to a convenient point. This particular rigid rod which is fixed at a point and has a turning effect is known as lever. So let us see the definition, very important definition which you have to learn for exam point of view. A lever is a rigid, straight or a bent bar which is capable of turning about a fixed axis. So you can see over here, fixed axis is known as fulcrum. Okay, the word fulcrum is important. You're going to use it again and again. Load and effort. So it can be a bent or it can be a straight rigid bar which is fixed at one point and it can turn around this fixed axis, and because of that you will see that sometimes the MA mechanical advantage is more than 1, mechanical advantage is less than 1, and it is equal to 1. So let's see. Now class 1 lever. In class 1 lever, what you are going to understand is the position of fulcrum. The fulcrum is between the load and the effort. So load and effort, whenever you're talking about load, you are going to show the arrow in downward direction. And effort you're going to show in upward direction. And fulcrum is at the center. So this is how you're going to represent in a schematic diagram, because in paper they will ask you draw schematic diagram for class 1 lever. So when they ask you to draw schematic diagram for class 1 lever, you're going to show a straight line. You're going to show fulcrum with a triangle, load with downward arrow and effort with upward arrow. Here you can see that load is in downward direction and effort is in upward direction. So this is how you are going to represent in a schematic diagram for class 1 lever. Now we are going to see the different examples of class 1 lever. So here you can see pliers. So if it is asked, plier is which kind of lever, which type of lever, which class of lever. So here you are going to see that fulcrum is at the center, load is at one end and effort is at the other end. So if fulcrum is at the center, it's going to act as a class 1 lever. Similarly, you will see spade, okay, which is helping to turn the soil. So here also fulcrum is at the center, load and effort are on the either side. So this is the load which you're going to try to turn with the help of this spade, and this is where you're going to apply the effort. So this spade is a class 1 lever. Again, shears. Here you can see fulcrum is at the center, effort and load are on the either side. So this is again class 1 lever. Here you can see fulcrum is at the center, load and effort are on the either side. So seesaw is class 1 lever. Now when you're talking about seesaw, if they tell you that the load arm and the effort arm, which I'm going to talk in the next slide. So, we are not going to talk about MA right now. You have to just understand how to identify the class of lever. So if fulcrum is at the center, load and effort are on the either side, then it is class 1 lever. Here also you can see that spoon used to open the lid. So fulcrum is at the center, load and effort are on the either side. So it is class 1 lever. Now here you can see the claw hammer. Claw hammer, the fulcrum is at the center, load and effort are on the either side. So claw hammer is class 1 lever. These are all from your textbooks. So children, it will be asked in the exam, claw hammer, pliers. So you should know which class of lever it is. Sometimes even examples are asked, so you should know to write. Here you can see handle of the water pump. The fulcrum is at the center. Load and the effort are on the either side. So even this is class 1 lever. Now here, if it is asked, the oar, okay, which is used to row the boat. So here you can see that it is fixed at this point. So fulcrum is at the center, load and effort are on the either side. So it is class 1 lever. Now we come to the class 2 lever. Class 2 lever, in this case, pivot means the fulcrum. You can use the word pivot or fulcrum. It's best to use fulcrum. So in this case, you have to remember load is at the center. Class 2. Okay. Class 2, always load is at the center. Class 1, fulcrum is at the center. So remember class 2, what is at the center? Load. Okay, load is at the center. So load is between effort and fulcrum. Now this is how you're going to draw the schematic diagram. Fulcrum with the help of triangle at one end. Load downward arrow, effort upward arrow, and a straight line. Now with different examples we are going to see. Suppose if they are asking you bottle opener, which kind of lever it is? Class 1, class 2. So you can see over here where it is fixed, this bottle opener, this point is the fulcrum. Okay, load is at the center. Because this is how you're going to fix it. The load will come at the center and effort will be at the handle. So this particular lever is class 2 lever. Again, nutcracker, you can see fulcrum is at one end, load is at the center, effort is on this side. So as load is at the center, nutcracker is class 2 lever. Then the third example is, here you can see a bar which is used to lift the load. So here also, this particular figure will be shown to you. So you can see that fulcrum is at this fixed point where you're fixing this rod. The load is the box which is at the center and effort is on this side. So as load is at the center, it is class 2 lever. Then the next example is wheelbarrow. As you can see, load is at the center, fulcrum is at one end, effort is at the other end. It is class 2 lever. Now we come to class 3 lever. Now as we have seen, class 1 fulcrum is at the center, class 2 load is at the center. In class 3 lever, you have to understand effort is at the center. So you can show schematic diagram, pivot, that is the fulcrum at one end, effort is at the center with upward arrow. Load is always shown with downward arrow. So at one end, then the other end. So here you can see, you have to remember what is at the center, children. So class 1, fulcrum, I repeat. Class 2, load at the center. And class 3, effort at the center. Very important part of this chapter. Now let us see the example. Now this is foot threadle. You have to only know these examples which are shown in the picture. Sorry. So foot treadle, you can see effort is at the center, fulcrum and load on the either side. So as effort is at the center, it is class 3. Sugar tongs, load, um, effort at the center and fulcrum at the other end, load and fulcrum, effort at the center. So sugar tong is class 3. Knife, you can see here also effort which is applied, because when you're holding the knife, that time fulcrum, the fixed point, is at your hand, and the load what you're cutting and effort is at the center. So again it is class 3. Spade, lifting a load. So you can see spade when you're using this kind of spade. Okay. So this kind of spade, your effort is at the center, fulcrum and load are on the either side. So in this case, this particular spade is class 3. So children, I hope till here everything is clear. So please revise it and then write it down. Whatever terms are mentioned, please learn it. Those are very, very important. Thank you, children.